Hello there, welcome to week 9. This video is recorded first for week 9, but it's an assignment solving video for week 8, and we'll upload it after the deadline for assignment for week 8. So in this video, like we did for other weeks, I'll walk you through the assignment and also tell you how we go about answering the questions. So if you remember, week 8's assignment was regarding syntax based testing. I had introduced you briefly to regular expressions in context free languages. We have two questions, small easy ones that test these. I had also introduced you to mutation testing, mutation operators that you could use at a unit level. So like we had for every week, there are 10 questions for the assignment. Most of them multiple choice, fill in the blanks, true or false, and each question carries 1 mark. So per slide, I'll walk you through one question, give you the answer for that question, and tell you how I came about with that answer. So the first question for week 8 assignment reads as follows. It gives you a regular expression, which is this, a into a plus b the whole star into a, and it asks the following question. It gives 4 options for languages, and it asks which of the following 4 options actually describes the language accepted by this regular expression, corresponding to the regular expression over the finite alphabet a, b. The 4 options that were given are, the first option says it's a set of all words over the alphabet a, b that end with the letter a. Second option says it's a set of all words over the alphabet a, b that begin and end with an a. Third option is a set of all words over the alphabet a, b that only begin with an a. Fourth alphabet says L is sigma star. Read sigma star as for sigma is equal to a, b, the set of all words over a, b. Which of these 4 options is correct? The correct answer, as given here, is the second option, which is the language of all words that begin and end with an a. Why is that a correct option? Now, if you go back and look at the regular expression, there is a, and then this is concatenation operator that I told you about, and then this is union of a, b star. We saw this particular entity, I explained it in the lecture. This means the set of all words over the alphabet a, b. It could begin with a, it could begin with b, it could have any occurrence, any combination of occurrences of a, b. But whatever it is, after that it's concatenated with another a. So to begin with, there is an a, then it's any word over a, b, and then it ends with an a. So second option, which says the set of all words w that begin and end with an a, is the correct answer. It cannot be the first one, because first one will include the words that begin with b also, where this irregular expression will not admit that word. And the third cannot be true, because it symmetrically omits the end condition. So which means it will include the set of all words that end with b also. Just beginning with a is not enough. For this regular expression, for a word to correspond to this regular expression, the word must begin and end with an a. So second option is the correct option. We'll move on to question number 2. Question number 2 was related to context-free grammars and context-free languages. So it gives you a context-free grammar as follows. Every context-free grammar, if you remember, is described by a 4-tuple n, t, p, s, where n is the set of non-terminals, t is the set of terminals, p is the set of production symbols, and s is one special non-terminal called the start symbol. So in this grammar, the set of non-terminals is just the start symbol s. The set of terminals or the alphabet is the set a, b. The set of productions is a set consisting of these 2 rules. The first rule says if you have a non-terminal s, you could replace it with the string a, s, b, or second rule says if you have a non-terminal s, you could replace it with the string a, b. And the question asks, it gives you lists of words, and it asks you which of the following is the list of strings that contain words that are generated from this grammar. We are not asking about a question about which is the language generated by this grammar. We're just giving some sample words in the grammar and asking you which are the words that are generated by this grammar. The list of words by no means corresponds to the entire language. So if the first option says these are the words AB, AAB, ABB. Now if you think about it, are these words generated by the grammar? Let's look at them one at a time. the word AB, that is generated by the grammar, because I can use the second production rule, S goes to AB, and derive the word AB. Is the second word AB generated by the grammar? We'll have to see. So if I begin with the second production rule, I can't apply any more production rule because there's no non-terminal on the right hand side. So I don't begin with the second production rule. So the only other rule that is available is the first one. So I begin with that. So I say S goes to A, S, B. I apply that rule. So in this case, I have already generated one A and one B in the string AAB that I am considering. I've already generated one A and one B, which means for this word to be completed, I have to just generate one more A. Is it possible to generate just one more A? I need a production which says S goes to A. Do we have a production like that? No, we don't, because we don't have it. This word AAB cannot be generated by the grammar. Symmetrically, this word AABB also cannot be generated by the grammar. Why is that so? Because again, I can start only with S goes to A, S, B. I start with that. I've already generated one A and one B. I just need to generate one more B, which I can't because I don't have a production rule that generates a single B at all. So the first is not a correct list. Second, is it a correct list? It could be a correct list, but because it is just AB. The third is a better list because what it says is that it gives you three words: AB, AABB, AAABBB. If you see, the way the production rules apply in this grammar is that for every A that is generated in this production rule, the first production rule, there is exactly one B that is generated every time this is applied. And finally, when you decide to end the derivation by using the second production rule, you generate one A and one B. So the invariant that you maintain in your sentential forms that you derive out of this grammar is that the number of A's is always equal to the number of B's. So the list, the second and the third list have that option, and in addition, A's are generated before B's. So the third listing is a list of correct strings generated by the grammar. We already saw that the fourth one cannot be a correct option because it contains the words AAB and ABB. Both of these are not correct, as we discussed for the option 1 above. So 4 is also not a correct option for this. Now let's go on to question number 3. Question number 3 was a fill in the blanks question. It asks you the following. If a test case satisfies just the conditions of reachability and infection, that is in the 4 conditions R, I, P, R model, only R and I, reachability and infection, are satisfied, then what sort of a killing of a mutant is that? The answer is, if it satisfies only reachability and infection, then the test case is set to weakly kill a mutant. If you remember, we had initially just defined the notion of killing a mutant. Later, I had refined it to weakly killing and strongly killing a mutant. For weakly killing a mutant, just infection and reachability are enough. For strongly killing, I should do reachability, infection and propagation. The output should be different. So here I have just said reachability and infection. So the correct answer should be weakly killing a mutant. Question number 4 is a true or false option question. It reads as follows. It gives you a statement. Higher mutation score indicates effective testing. Answer is false. Why is that false? If you remember, what was mutation score? Mutation score gives you a number of test cases or the mutants that were killed by as minimal a test cases as possible. And when I defined mutation score, right then I had told you that if you have great mutation score, it doesn't mean that the program has lesser errors. If you found more and more mutants and written test cases to kill more and more mutants, they need not correspond to errors in the program. Because additional mutants, increased number of mutants need not correspond to errors in the program, higher mutation score does not mean effective testing. Question number 5 was another fill in the blanks question. It reads as follows. It is a question about this mutation operator that we saw as a special case called fail on 0. It asks you, what does the mutation operator fail on 0 do? It causes the argument to become 0. If you remember, why did we have this operator? The idea of having this operator was when the developer is doing unit testing, he is supposed to be responsible for making every variable 0 and test program behavior for that variable. This mutation operator fail on 0 does precisely that. It makes every variable 0 and tests the program for the 0. So it just causes the argument to become 0. For questions 6 to 10, the last 5 questions, I had given you a small method along with one mutant of the method, and I had asked you some questions about the method and its mutant. So we'll go through the method and the mutant of the method first. So the method name was called findVal. What was findVal trying to do? It will throw a null pointer exception if the array of numbers, there is an array that it takes called numbers, and along with a value, and it's supposed to find the position of the value in the array. If the value occurs more than once in the array, it's supposed to return the last occurrence of the value in the array. If the value is absent in the array, then it's supposed to return a special position called -1. And if the array is a null array, then it's supposed to throw a null pointer exception. This was the main method. In the code of the method, in line number 4, there was a mutation that was given to you, which was denoted by triangle 4. So we'll see the method. So the method reads as follows. There is an array of integers called numbers, and there is an integer value called val. This method findVal is supposed to check if this integer value val occurs in this array of numbers and return the last occurrence of val in this array. If val is not found, it is supposed to return a -1, as I told you. So how does the method work? It begins by initializing what it's supposed to return as -1. It will reset it when it finds value, and as and when it repeatedly finds value, it will keep resetting the position so that it can return the position of the last find of the value. Then it enters into a for loop that begins at 0, goes all the way till the length of the array. And what does it ask per element in the array, numbers of I? Is it the same as val? If it is, then you change the index findVal to be that index of the array. Keep doing this. This will by default update the index if val is found again and again. And when it exits for the last occurrence of val, the number that it returns will be the findVal that it returns will be the last occurrence. So that's the main method. This method has a mutant, which is denoted by delta 4. As I told you during my lectures, how do I read the mutated program? You take out line number 4, instead replace it with line number delta 4. So the mutated version has the same method, but what is the difference? Instead of the for loop as given in line 4, it contains the for loop as given in delta 4. What is the difference between for loop given in line 4 and for loop given in line delta 4? The difference is array indexing in the for loop in the original method begins at 0, and in the mutated program it begins at 1. So the mutation that we have made is we've just changed the array index to begin from 1 instead of beginning from 0. So then you were given 5 questions in the assignment about this method and its mutation in line 4. So the first question was a simple true or false question. It asked the following: is it always possible to reach the mutant in line 4? The answer is true. We'll see why. The answer is very simple, because the line 4 is right in the beginning. It's in the second line of the program. It's in the second line of the method. The first line is just an initialization of this variable called findVal. Second line is the for statement. So you can obviously reach. It's not embedded inside any if or while or anything like that. So reachability is always true. The next question asks, is it possible to find a test input that satisfies reachability but not infection for the mutant? So what do we mean by reachability but not infection? Reachability means you reach line number 4, the mutant in line number 4. I told you reachability is always achievable. But can I find a test input that causes reachability but does not cause infection? What does infection mean? Infection means that the state of the program at the given point in time is different. Is that possible? The answer is no or false, because I have changed the array index from 0 to 1. So the state which gives the values of the numbers in the array is going to be different for the original program and for the mutated one. Why? Because the mutated method is not going to compare val's occurrence in the 0th index in the array. It is directly going to start checking if val occurs in the first index in the array. So the answer is false. Question number 8 is a simple yes or no question. It says, can reachability and infection occur even if the input is null? Please remember, what are the inputs to the method? The inputs to the method are the array of numbers, array of integer numbers called numbers, and a value to be found in the array. So if this is 0, definitely reachability will occur, because this line number 3 will get executed anyway, and the line number 4 will be occurring. So reachability definitely occurs. What about infection? Infection will also occur, because the array is 0. One checks for index 0, one checks for index 1. So the checks are going to return different values. So the answer is yes. So next question says, which of the following is true about the test input numbers, which is an array of length 2 given as 1, 1, and the value to be found in the numbers array is just the value 1. So this is my input to the method. The input is array of numbers called numbers, is an array of length 2 which has number 1 repeated twice. The value to be found is 1. So it says this input for that mutated program and the ground string, which are the two conditions that it satisfies. The given test input satisfies infection and propagation. The given test input satisfies infection but not propagation. As we told you, every test input will satisfy infection. That's what the question for this question number 6 says. Every test input will satisfy reachability and infection between question number 6 and question number 7. What it says is that which of these make propagation true. Propagation means what? The original program with this line number 4 returns one index. The mutated program will return another index. Original program begins checking from the first 0th index of the array. Mutated program checks from the first the 1th index of the array, which is actually the second in line. So if you see, this is the original program will return the index of finding value to be 0. Mutated program will return the index of finding value also to be 0. So they don't satisfy, they satisfy infection, but they don't satisfy propagation. So what is an input that will satisfy infection and propagation, or what is an input that will strongly kill the mutant? So that's the last question about which of these two inputs will strongly kill the mutant. The first option says any input with val only in numbers of 0 will strongly kill the mutant. Second option says no input can strongly kill the mutant. The answer should be reasonably clear. It is the first option. Why is the first option the answer? It says val is present only in numbers of 0, which means it's present in the 0th index, the first occurrence in the number array. So the original program, which runs its for loop from 0, will return correctly as val present in position 0. Whereas the mutated program, which runs its for loop from 1, will miss the presence of val in position 0, because it begins its for loop at position 1. And what will it return? The mutated program will return -1. So the original program will return 0, mutated program will return -1. For which value? The value, if the any input val is such that val is present in the array but in the 0th position in the array, right? So this will definitely end up making the output of the original program different from the output of the mutated program. That in this is the same as strongly killing the mutant. So the correct answer is the first option. So I hope this video was useful for you to be able to cross check if you've answered your assignments correctly, and if you've got the marks. Feel free to ping me in the forum if you have any further clarifications or doubts about any of these things that we learned last week. Thank you.